Okay, so these are parts to a regular polygon that you're going to have to be able to identify or mark on your own if not given. Alright, so we're going to use this picture to the right to give examples of the parts. So the center of a polygon is the center of its circumscribed circle. So what's the center of the circle? P. So P is also the center of the polygon. Okay? Alright, P. Point P. Alright, then the radius of the polygon, the radius of the circumscribed circle. So, huh? PM is one of the radius. That's a radius right there. So PM is an example. There's another one. PN. Yeah, and PN. Notice that for it to be a radius, it goes from the center to the corner of the polygon. Okay, so PM and PN are radii. Now, the apothem of a polygon is the distance from the center to any side of the polygon. So what segment would be the apothem? Yeah, PA. PA is the apothem. It's from the center to the side of the polygon. Now, the other thing you need to add to your little examples that we have here, just saying also, another side note, the apothem is perpendicular to the side of the polygon. Now, the reason why I'm saying this because a lot of times in the diagram they don't denote that. They expect you to know it and to use that relationship. So it is always, distance is always perpendicular, so the apothem is perpendicular, so you are expected to add the box. You are expected to add the box that is perpendicular. Alright, so PA was the apothem. Now, they want us to find the central angle. The central angle of a regular polygon is an angle formed by two radii drawn to consecutive vertices. So we're just going to mark where that central angle would be. It's got to be formed by two radii. So where would the angle be? MPN. Yeah, MPN. It would be right here. So go ahead and put the arc there to show where the central angle is. The example that we're going to write, we're just going to name it MPN. I'll go up. I know some of y'all need that. MPN, or I could say NPM. Order doesn't matter. What matters is P has to be in the middle to show it's the vertex of the angle. Now, with that being said, do you see the triangle that we created, or that is created in the interior of the polygon? Meaning, I'm looking at the triangle. Yeah, they already told us. MPN. So we got M, P, and then N. They want to know what type of triangle would that be by its sides? Yeah, it is isosceles because aren't these two radii? And the radius are congruent. Okay, so this would be an isosceles triangle because of the two congruent radii. You need to add that to your notes. Being able to recognize the parts is going to be the key to do these type of problems. Now, it says, how does the apothem relate to the triangle APN? So basically, here's our apothem. This was the green segment right here. How does that relate to the triangle? What is it? Not half, close. What part does that represent in the triangle? The height. The apothem is the height of the triangle. What else could I call? What else is it doing? If this is a isosceles triangle, okay, that's the height. The apothem becomes a perpendicular bisector. It becomes an altitude as well. It's still going to be base times height divided by 2. You're right. All right, so they want to know if, because this apothem is a perpendicular bisector at an altitude, it's going to bisect the angles. that's going to bisect the central angle, the angle that I marked as red. So angle MPA is going to be congruent to what other angle? If I'm looking at MPA, yeah, you can say APN, NPA, but we have to see that these two parts are getting cut in half, and these two angles are going to be congruent. All right, because it's also a perpendicular bisector, the base of the triangle is going to get bisected as well. This only happens in an altitude triangle. The altitude does that. So, A congruent, yeah, AN, or NA, yeah. Both of them are right. Alright, so what we're going to go straight into, hopefully you have these examples, because we're going to, now I'm going to give you numbers, and now we're going to see, can you give me the parts or its measurement? So go to the next slide. Go to the next slide. Alright, in the diagram, ABCDEF is a regular hexagon. Alright, y'all do recall what regular means? For it to be regular, what has to occur? Regular hexagon. Yeah, you're gonna have two things. You're gonna have congruent sides, and you're gonna have congruent angles. Okay? So for any regular polygon means that all the sides are gonna be congruent, all the angles are gonna be congruent. For this one, they said it's described in circle G. DE is gonna be 8. They want us to find the following based on what we know about the parts in a regular polygon. So the first thing they want us to find is find the measure of angle EGF. So EGF, here's the E to G to F. They want me to figure out that angle. Andy? I don't. Yeah, so he's right. Like if I connect the radii to all the vertices, y'all see how many triangles we would have in here? Total? Yeah, 6, right? So if you're going all the way around, so to find the angle, yeah, 360 divided by 6. So the angle in the interior, or the central angle, is 60. With that being said, if I know that the angle here is 60, yeah, so they said EGH, this would be 30. It would be half of it. 60 divided by 2, that's 30. So now they're asking you to find what would the measure of HEG be. H to E to G is over here. Yeah, it's 60. You see you have a right angle here, a right triangle? So we know 30, 60, 90. That's 60. Alright, so they want us to find the measure of FE. It is also 8 because we have a regular hexagon. That means all the sides are going to be 8. This is a regular hexagon. HE, FE is 8 because they gave me DE, which was 8. It's a regular polygon. All the sides are congruent. Yeah, HE is 4. That is correct. Because it's half of the side, yes. Alright, now we got to figure out GH. GH. Okay. Alright, do y'all see the right triangle in here? That is what you're going to have to be focusing on for these type of problems. That is what you're going to have to draw because it's not going to be given to you. So, excuse me. All I want you to do is we're just going to redraw the right triangle that's inside of here to the side and label the parts. So I know the vertex angle up here is 30. The angle on the base is 60. We know that this leg is 4. Okay? We are trying to find the apothem. You could use that. I can't use Pythagorean theorem because I only have one side. So, well, I would use the fact that I have a 30 and a 60, which means this is x, this is 2x, and this is x radical 3. This is a special right, 30, 60, 90. Okay, guys. To get the hypotenuse, 2x means I'm just saying 2 times whatever x is. Okay? I don't want the hypotenuse. I want the a. This is over here. That means you're doing x times radical 3. X is the short leg. What number is the x in our picture here? 4. This is your x. Okay? So to get to the apothem, all I'm going to do is take that x and times it by what? Radical 3. So I'm just going to say 4 times radical 3, which would just give me 4 radical 3. Alright, so now we know the size. You should be able to figure out the perimeter. You would have to check. If you trig, you have to check that your decimal gives you the same radical. Like you would check the radical, gives you the same decimal. But I heard it. How did you get the perimeter? 6 times 8, so you should get 48. Okay, 48. Alright, so there are 6 sides, and they're all 8. Alright, if you have a highlighter, get it out or use the one maybe in the box at your station. These are the steps you're going to have to follow. We're going to practice this in class, and you're going to have to memorize these steps. I'm sorry. Yeah. Did you just say? I got to. Okay, so there are 4 steps that you're going to have to do on your own, that you're going to have to memorize, apply to your regular polygons. And this is when the apothem or the side is not given. Okay, and we're going to practice what we did before it was given to you. Now we know what to do. The first thing is find the measure of the vertex angle in the right triangle. That means that you're going to end up drawing a right triangle in your regular polygon. Just for this formula, to find that vertex angle, this n represents the number of sides of the polygon. So n is going to be your number of sides of the polygon. Excuse me. I said label the given and the degrees of the right triangle. Because you're going to have a right triangle, you're going to have to draw the right triangle. That is not going to be given for you. So make sure you know you will have to draw that. Then you're going to determine which trig function to use to find the missing side. You could also, or you could use special rights, which we're going to practice because we still need it. Okay. Or you can use special rights. But trig could give you your answer. The only difference is trig is going to give you an approximation. Special rights is going to give you the exact answer. The last thing is you got to substitute and solve to find the area. When you substitute and solve, you substitute in this formula. A equals 1/2 A times P. So 1/2 A times P in the formula. Just understand that A is your apothem and your P is your perimeter. Okay? So we're going to do some guided practice before we leave for lunch to make sure you have an understanding of the steps and what you're going to be expected to do. And we're going to do some more practice when we get back. So, everyone have the steps? Yeah. Okay, so here are our guided practice problems. The first step, the first thing you have to do is use this formula, 1/2 times 360 divided by n, because you have to find the vertex angle. So that is our first step always, unless it's given to us, which it will not be given, so you have to do it. So, how many sides does this shape have? 6. So I'm going to plug in 6 for n. So basically I'm going to have 1/2 times 360 divided by 6. Okay, what is 360 divided by 6?
60.
So what's a half of 60? 30. So our angle is 30 degrees. Now, our step 2 says that we're going to label the given degrees to the right triangle. In this problem, in your problems, no right triangle. Do you see the right triangle in your figure? No, so we have to draw it. The triangle has to go from the center straight down, make that perpendicular line, which is the apothem. The apothem is part of the right triangle. And now that I know the 30 degrees goes to the vertex angle that goes at the top. Okay, yep, since that's 30, then I know the other one is 60, okay? And the hypotenuse is 6. That is correct. So, do you see? I'm just going to redraw right here so you guys can see, just bigger. If the hypotenuse is 6, what could you find? Yeah, one of the, not 6, but what is one of the sides? If the hypotenuse is 6, 3, you're right. Which one is 3? The bottom. The short leg is 3. You just divide by 2. Huh? Yes, so the long leg, okay, would be 3 times that. 3 times radical 3. It's 30, 60, 90. Yes.
So what would be the exponent like radical?
So this, the apothem, this right here is 3 radical 3. Okay? So that is the A right there. Okay? So we know, now that I have my right triangle, I don't have to use trig, I did my special right. I'm now going to label the triangle, and now I'm going to use my formula. My formula says I'm going to do 1/2 A, the apothem, times P, the perimeter. Okay? We know that the A is the 3√3. A is the perpendicular distance. What? Now we got to find the P. P is your perimeter. Okay? So think about this. I know that this little part here is 3. What if I drew the line that way? This would be 6, right? Wouldn't this be 3 again? So the whole side is what? 6. The whole side is 6. Boom. So now that I have all this, I have the whole side is 6, I can get the perimeter all the way around. 36. So we know the perimeter is 36. The whole thing, the polygon. Okay? I'm doing the perimeter of out here. Okay? Alright, so now I got my apothem. Now I got my perimeter. I'm just going to plug it into the formula. So I'm just going to rewrite it to say 1/2 times, I'm going to do parentheses, 3√3 times 36. Okay? Now, think about this. Which number can I take half of? 36. Okay, what's half of 36? Not 6. What's half of 36? 18. Okay. Half of 36, 18. So I'm going to say 18 times 3√3. I took half of the 36. Now I'm timesing it by the apothem, which is 3√3. So which numbers do I multiply together? Yeah, 8, the outside, the 18 and 3. All right, what's 18 times 3?
54, so it's going to be 54.
Yeah, 54√3 is the area. Now I'm going to show you a shortcut that happens with with the hexagon. Only with the hexagon. And I want you to see a pattern. Okay, so you see this side was 6, right? Okay, do you see this part in the triangle? The hypotenuse? Do you see that they're the same? Okay, this only happens in a hexagon. So if I know the side, then I know the hypotenuse. If I know the hypotenuse, then I know the side. They're always going to be the same. Do y'all see those two parts? Y'all know those two parts are not going to be the same for what shape? Hexagon only. Okay? You can only do this with the hexagon. And I'm showing you this because this is the most common shape that is used. All right. So, do you have the right triangle here? No. So the thing we got to do first is draw it. Go from the center, go straight down, create your right triangle. What part did they give you? And that 10 represents the side, which will be also the hypotenuse. So that's 10, right? The bottom little part here is 5. Yeah, 5 radical 3. We're done. Because now we have pretty much all I need. I need my apothem, which is 5 radical 3. I need my perimeter, which is, I have my sides and I can find that. Perimeter. 60. Okay? So now all I got to do is plug it in to 1/2 A times P. So I'm just going to say 1/2. My apothem is the 5 root 3 times my perimeter, which is the 60. Yeah, so I can take half of the 60, right? What's half of the 60? So now I'm saying 30 times that 5 root 3. Yeah, 150 root radical 3, and that's my area. That's it. Okay? All right. We're stopping right there.